Thank you, Mr. Nair.
My ninth grade, I miss you guys, I really do.
They called him simply the Renaissance Man. Let's give a hand for Mr. Nair, please. Everybody, let's go. The Renaissance Man. Excellent. Excellent. Okay, now, so let's run through these quickly, okay? We did about 4 since we had our last video, correct? So let's do these quickly. We should be getting good at these now, right? Nitrogen is 5, hydrogen is 1, 3 hydrogens, 1 nitrogen, 8. Right? Nitrogen is central. Kind of gave it away a little bit, the geometry. Okay? 6, 2. These are all satisfied. They don't get any additional electrons. I have 2 left over. Circle them if they're left over. Helps to remember. You got to put them here. Or is everything set? The big things. Outer atoms have to have a complete valence. They do. Hydrogen has to have 2. 2. Central atom, if it's a nonmetal, has to have 8 or more. It has 8. Therefore, it's going to look like this. There's my central atom. And then 1 at the back. And you're going to have this little non-bonded pair up there. And it looks like this. Looks like this. It's really not much out of the plane. We're going to do this with gumdrops when we get back.
What are gumdrops?
You know what gumdrops are? Can I get gumdrops in Abu Dhabi?
I don't know what it is.
Of course you can get
Gumdrops like circles.
Oh.
They put them on gym routines.
Yeah, they have them everywhere.
Just never had them.
Definitely for your.
Yeah, they have them everywhere.
Still don't know what
All right, guys, there it is. That's ammonia. It's called trigonal pyramidal. Girls, trigonal pyramidal. Non-bonded pair, 3 bonded pairs. Almost in the plane, but really not. It's kind of like a pyramid someone sat on, right? It's a pretty poor-looking pyramid, but it's called trigonal 3 pyramidal, okay? The next one we're going to do, we're going to skip one of them that we did. No, we're not. We're going to do all of them. Okay. I'm going to erase this quickly. Is that okay? Okay. I got 7 minutes to finish. I can do it. Okay. 7 minutes to finish. I can do it. You have BeH2, beryllium hydride. Now, you think of metal and hydrogen, ionic maybe, right? But what's the valence for, what's the electronegativity of beryllium? 1.5. Hydrogen is 2.1, so it's only 0.6. So it's probably going to be covalent. Yeah? Okay. So beryllium, hydrogen. We're going to do this quickly. Total valence, 1, 1, 2 is 4. Subtract off 4, 0. That's it. Nothing on the central atom. And 2 electrons, 2 pairs of electrons. It can only be linear. Think that non-bonded pair of electrons affecting the geometry. They control the geometry. They can make the geometry planar, straight, like a regular, right? Or it can make it linear. Or it can make it, the absence of them can make it linear. Or the presence of them can make it pyramidal, like trigonal pyramidal. All right, let's do one more, okay? Oh, by the way, metal, right? 8 less than 8 has 4, okay? Aluminum. Right? 777 and 3 is 24. Minus 6, 18. You with me so far? Right? Complete the valence. 2, 4, you have 2, each one has 2. Right? We did minus 6. And now to complete the valence, it says 2, you need 6 more here. 6 here, 6 here, that's 18. 0. Nothing on the central atom. It's going to look like this. Central atom. Central atom, sorry, you don't have to put, when you have those little things, you don't put the actual elements in there. That O just means the central atom. And it's going to look like this. Okay? It's going to look like that. Evenly distributed. And it's going to look like this. Trigonal planar. Right? Trigonal planar. Yes? You get it? Now, we're going to finish with this. You ready? Now, let's say that all of the dipoles, let's say this has dipoles, they're all the same. Is that going to be polar or nonpolar? Polar or nonpolar? Trigonal planar, all the dipoles are the same. Dipole, dipole, dipole. Polar, polar, polar. But what's that molecule going to be? It's going to be nonpolar. Because they're going to all cancel. Yeah? What about this? What about this one? Remember this one? I'm not going to put in the non-bonded pairs. Remember this planar one? Xenon tetrafluoride? Polar, nonpolar?
Non-polar.
Nonpolar. Cancels. Yes? Let your intuition work for you. What about water?
Polar.
Bent. Polar. Thank God it's polar. Thank God it's polar. Otherwise you wouldn't form the ice the way you form it. That's another discussion. What about ammonia?
Non-polar.
Polar.
I mean polar.
Look at them.
Yeah, yeah.
They don't cancel. Polar. So do you see how molecular geometry can influence polarity? All right. Now, I know I said I'm finished, but I'm going to do one more, and this is the classic one. Are you ready? Are you ready? Yeah, you ready? Cool. Okay. This is probably one of the most famous, one of the most stable molecules, the stablest geometries in nature. Right? 4, 1, 1, 1, 8, correct? Right? Carbon, hydrogen, 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 hydrogen.
Sir, it's 7. It's not 8. It's 7.
What do I do?
You put it.
No, it's 8, but you forgot.
You forgot one.
One of
Yeah.
those.
Thank you. Nice assist. Excellent. That's Mohammed. Excellent. Nice assist. 5 points extra credit. I like it. Okay. So, 8. 2, 4, 6, 8. So it's done, correct? Now, remember xenon tetrafluoride was 4 and it was planar? But be careful. That planar nature of xenon tetrafluoride was influenced because of the unbonded pair of electrons, correct? There are no unbonded pair of electrons here. There's only 4 bonded pairs. Looks like this. Look at this. See this? Every bond angle, every bond angle is approximately 109.5. They're all equal. What is this called? What geometry is that called? 4 equal bonds, no unbonded pairs. It is called a... Let's do another color. So excited. Isn't this exciting? Tetrahedral. One of the most, there's other ones. One of the most stable. You understand, you know what this is? You know what kind of geometry has this?
Diamonds.
Who said that?
What?
How did you know that?
I took it last year.
Excellent. It's diamond. That's diamond. What else is it? Believe it or not, it's ice, water ice. Why? This is bonded pair of electrons. That's bonded pair of electrons, right? Right? And this is unbonded pair. Why did I do that? Well, ice, you get 2 physical bonds because there's an oxygen here and an oxygen here. This is a physical attraction. 2 physical bonds called hydrogen bonding. Remember we talked about hydrogen bonding? Hydrogen bond, chemical bond, chemical bond. Physical, physical, chemical, chemical, but the shape is tetrahedron. Have you ever heard diamonds in the old movies from the 30s called, hey, you got the ice? Hey, Frankie, you got the ice, huh? You got the ice? You got the diamonds, huh? You got the ice? Yeah? Water or diamond, tetrahedron. There's a gas station oil company, I have no idea what it is, but anyway, it used to be called City Service when I was a kid, and now it's called Citgo. And their logo is Citgo over a tetrahedron. Hey, everybody, have a great holiday. Bye.